So again, let me recap. Welcome back. We said that performing a simulation is a four-step process. You state, plan, do, and conclude, which is answering your question of interest. So back at the beginning of this unit, we did a simulation where we determined what is the probability that 3 of 7 people who buy a 20-ounce bottle of soda win a prize if each bottle has a 1 in 6 chance of saying you're a winner. So that was our question. I should probably put a question mark here. And then our plan was that we used a 6-sided die to determine the outcome for each person's bottle of soda. And so we defined 6 as being a winner, winning a prize, and the numbers 1 through 5 as being no prize, so that we could have a 1 in 6 chance of saying you're a winner. So we rolled the dice 7 times to simulate each of the 7 people buying the 20-ounce soda. And then we recorded whether 3 or more people won by saying yes or no. And what we did was each of you performed at least 5 repetitions of this simulation. And what we could conclude, and this I just made up because I made the video before we gathered our class data, but let's say we did 125 total repetitions of the simulation, and there were 15 times when 3 or more of the 7 won the prize. Our estimate of the probability would be 15 out of 125, the part over the whole, which is about 12%. So that's how we use this to perform a simulation. Here's another example, similar example. Let's say NASCAR cards are in cereal boxes. And so in an attempt to increase sales, and you'll see this all the time when you buy cereal. Some of you probably when you were a kid, you bought cereal just because of the prize, or you went and got a kid's Happy Meal just because you wanted the little cute teeny tiny Beanie Baby or whatever. And so in an attempt to increase sales, a breakfast cereal company decides to offer a NASCAR promotion. So each box of cereal will contain a collectible card featuring one of the NASCAR drivers. I know nothing about NASCAR, but Jeff Gordon, Dale Earnhardt Jr., Tony Stewart, and Danica Patrick, or Jimmy Johnson. And the company says that each of these 5 cards is equally likely to appear in any box of cereal. So a NASCAR fan decides to keep buying boxes of cereal until she has all of the 5 drivers' cards. She's surprised when it actually takes her 23 boxes to get the full set of cards. Should she be surprised is the question. So we're going to design and carry out a simulation to help us answer this question. So the first place you're going to start is by stating what you think is a good question. So for state, you could say something like, what is the probability that it will take 23 or more boxes to get a full set of 5 NASCAR collectible cards? Okay, for our plan, you might want to pause the video and try to come up with a plan on your own and then check it with what I'm about to say. So we need 5 numbers to represent the 5 possible cards. So let's let a 1 equal Jeff Gordon, a 2 equal Dale Earnhardt, a 3 equal Tony Stewart, 4 Danica Patrick, and 5 Jimmy Johnson. And then we could use math, scroll over to PRB, rant interval 1, 5 to simulate buying one of the boxes of cereal, and then keep hitting enter, right? You're going to keep hitting enter until you've gotten all the numbers from 1 to 5, and then record how many boxes you had to open. How many times did you have to push enter to get numbers 1 through 5 would simulate how many boxes you had to purchase. And so what are you going to do? Well, you're going to go ahead and start doing many repetitions of the same simulation and record your results. And so what are you recording? You're recording how many quote-unquote boxes you had to buy, or how many times you had to actually push enter when you did a rant interval. And what are we going to do? We're going to record it on a box plot, and you'll see a box plot available there for you. And then last, you're going to come up with a conclusion. So you're going to find out, yours is going to be different than mine, but you could find out that how often did you have to buy 23 boxes to get all cards. And in this case, we're going to do 50 repetitions of our simulation. And you're going to record the probability that it takes, how many times did it take 23 or more boxes to get a full set out of 50. And in the simulation I did, I ended up with a probability of 0 because the highest I had was 22, which is possible. All right, so go ahead and complete this simulation. You're going to need a graphing calculator and to complete your state plan and do on your note sheet. Then you're going to make a box plot, I'm sorry, not a box plot, a dot plot, and then write your conclusion. And again, remember, a good conclusion, let's go back to this example. A good conclusion talks about the total repetitions you did. In this case, it should be at least 50, and how many times that outcome occurred, and what your probability, your theoretical probability would be. All right, here's another example, and this one I'd like you to partner up with somebody. Of course, you got to partner up randomly, and you're going to do the taking the train activity that's on your note sheet. Get it checked and make sure you're following that 4-step process. So I'll check it as you come up to me and you finish. And then you can go ahead and get started on your Khan Academy. And the Khan Academy that you will be doing is over here on your note sheet. You're going to do randomness, probability, and simulation. And the practice section is called Interpreting Results of Simulations. And I believe there are 7 questions that you need to get correct. And if you look on your note sheet, you also see all this needs to be completed. And here's the taking the train activity that you're going to complete right here. All right, good luck, guys. And I will talk to you later.